The first thing you're going to do is open up to that pink divider that you've glued in your notebook. Our first topic in this unit was absolute value. We're moving on to our second topic, NS2, which is perfect squares and square roots. We're going to start with perfect squares today, but we're going to list both of them under topic 2 because they kind of go hand in hand. So make sure to take a moment and get your divider caught up with our topics. Alright, so now we're going to flip over to the next page after our absolute value notes, and you should have your notes glued in for perfect squares. Alright, so perfect squares we actually started on Friday when we used our colored tiles and that graph paper where we drew the squares on the graph paper. And what this first question is getting at here is actually relating to what we did on the graph paper. It says, how can I write, and this is 9 times 9, that little asterisk means multiplication, so how can I write 9 times 9 in a condensed form? So if we look back at the graph paper that we used on Friday, we wrote out, for example, 2 times 2 equals 4, and then in a condensed form we used that little small 2 up in the corner to show that we were multiplying 2 times itself. And we did the same thing here with 3 times 3 to give us 9, and we said we could use that exponent, that little small 2, as like a shortcut way of writing 3 times 3, because you're multiplying 3 times itself. And we did this all the way up to 10. So if we wanted to similarly write 9 times 9 in condensed form, in fact you actually could look back at your paper and see what we wrote, but we would use that little 2 in the upper right hand corner. So you would write it like this. And that little 2 again means that you are multiplying the number by itself. Now you would read this as, and I think I said this when we were doing our graph paper, but you would read this as 9 squared. So we're going to write out all of that so you know exactly how you would say it. And another way that you could say it, which as you can see is a little bit longer so you don't hear it as frequently, and when we start using other little exponents up in the top there other than 2, you'll have to use this other way of writing it or saying it. But other than 9 squared, you also could say 9 to the second power. So most people normally just say 9 squared because it's a little bit faster and easier to read it that way, but 9 squared or 9 to the second power. So a very similar example next. How can I write 4 times 4 in condensed form? Same idea. I would use that little 2 to show that I'm multiplying the 4 times itself. And I would read that 4 squared. And again, if you wanted a little bit longer way to say it, which you would need to use if you had other exponents besides a 2, but you could also read it 4 to the second power, just like we did with 9 to the second power. So 4 to the second power. If you had an exponent of like a 4 or a 5, you would say like 4 to the 4th power, 4 to the 5th power. So you can also say that if it's a 2, you can say 4 to the second power, but again we normally say 4 squared because it's just faster. Now I've already kind of gotten to some of this vocabulary here. We want to talk about the different parts here. When you have that big number and that small number, they're using just a variable of x for the big number because that means we could replace it with anything. So it's not necessarily an x they're talking about. They're just talking about the big number. And the little number. So that little number I've already mentioned a few times, and we tend to talk about it a little bit more. And that small number up in the corner would be your exponent. So you don't have to have an exponent of 2 in this unit. We are going to be having an exponent of 2 throughout the unit, but you could have any number up there. That little number, that exponent, just tells you how many times you multiply that big number times itself. And that big number, big and the word for the big number both start with B. That big number is called the base. So you have the base, which is the big number, and then that exponent, which is that little small number up in the corner. So squaring a number means that you're raising it to the second power. So the exponent will always be a 2 for something that is squared. So a perfect square is the square of a whole number. So that's what's important here, which means you multiply that whole number by itself. So we're not multiplying a decimal or a fraction times itself. We're not multiplying like 1.5 times itself. It has to be a whole number you multiply by itself in order to be a perfect square. So, for example, we would have 1 times 1, which of course is 1. The 1 that I've written in pink, that is the perfect square because that is what I get when I multiply a whole number times itself. And the whole number happens to also be 1. 2 times 2, the perfect square would be 4 because 4 is the number that I get when I multiply 2 times itself. And 3 times 3, of course, is 9. The perfect square is the 9. The 3 is not the perfect square. The 3 is the number I'm multiplying by itself to give me the perfect square. So the numbers I've written here in pink are the perfect squares. So the product of multiplying a number by itself is called the perfect square. So product and perfect square both start with P. So you can remember that it's the product that's the perfect square, not the number you're multiplying by itself. All right, now looking at some of the examples with the models that are portrayed here. So these again would look very similar to what we did on our graph paper last week. So this first square right here, I'm going to look at the side length. So the side length, both on this side kind of going up and down, and this side going left to right. This side would be 3, and this side going across would be 3. So we would say that our side length is 3. And if we square our side length, I know that's a small 2, but probably should have made it a little bit bigger. But if we square that side length, that is going to give us our total number of squares or tiles within that big square. So if I count all of these up, I would have a total of 9 squares within that big square. And so 3 squared would be equal to my total, which is 9. If I look at the next example, along the side here, that would be a length of 4, and kind of left to right here along the top would also be a length of 4. So my side length is 4, and my total, or my area, if I count up all those boxes, would be 16. And 4 squared would then give you 16. So we were looking at comparing our side length to the total number of squares or tiles within our bigger square. Next one, you would have a side length of 5, both directions. So I'm going to square my side length to figure out the total number of squares that we have, which if you count all of these up would be 25. So 5 squared is 25. And in this last model here, you would have a side length of 6 on this side by 6 on this side. So your side length is 6, and you square it, which would give you a total of 36 squares in the big square. So 6 squared is equal to 36. So when we were finding the perfect square, what we were doing when we were multiplying 3 times 3, 4 times 4, 5 times 5, 6 times 6. I'm multiplying the length by the width of the square. It's just that they happen to be the same because it's a square. So whenever you multiply the length times the width, you are finding the area. So when you were finding the perfect square, in this case, you're finding the area of the square. Now there is a perfect square we were not able to model either with the tiles or with our graph paper, and that is 0. 0 is a perfect square because there is a number I can multiply by itself to give me the 0. So right here is the perfect square kind of after the equal sign, because again, I can multiply a number by itself to give me 0. What number can I multiply by itself to give me 0? That also happens to be 0. So 0 times 0 is 0. This is the part we're talking about with the perfect square here. It's just that it so happens you're also multiplying 0 by itself to get me that 0. It's kind of like 1, how you can multiply 1 by itself to get 1. So that's one of those weird ones. But you can't really draw a picture of it or model it because it's hard to draw a picture of a square that has a side length of 0. Or make a square using 0 tiles. So you just have to recognize that it works, but you can't really draw a picture of it. And down at the bottom here, we have a couple examples of what I would do if I forgot my perfect squares. So we're going to work on memorizing them because of the fact you won't have a calculator for this part of our unit. But if you forget a perfect square, especially some of these bigger ones here, like 17 squared or 18 squared, it's not the end of the world. You know how to multiply. And it may have been a while since you multiplied two-digit numbers like this. May have been something you did back in elementary school, but we'll do a little refresher of it here just to make sure you know how to handle this if it were to happen, if you needed to know a bigger perfect square that you'd forgotten. So 17 squared means 17 times 17. Now I just have a multiplication problem to solve here. So I would start by multiplying 7 times 7, which would give me 49. So I write the 9, carry the 4. Now I multiply that 7 times the 1. So 7 times 1, of course, would give me 7, plus 4 would give me 11. So at this point, I'm at 119, but I'm not finished yet. I would still have to multiply everything by the 1. So I'm going to cross out this 4 because I've already used it and I don't want to accidentally factor it in again. So this is where I use a 0 as a placeholder and then I multiply everything by the 1. So 1 times 7 would be 7 and 1 times 1 would be 1. I add up these numbers. 9 plus 0 is 9. 1 plus 7 is 8, and 1 plus 1 is 2. So that means that 17 squared is 289. I can do that by hand if I need to. You can memorize them, it makes it a little bit easier. And the same idea for 18 squared. 18 squared means 18 times 18. So I'll do the same thing. I'll multiply the ones column here. So 8 times 8 would give me 64. Write the 4, carry the 6. Now I multiply that 8 times the 1, which is 8, plus that 6 I carried would give me 14. All right, I'm done multiplying everything by 8. I've already factored in that 6, so I'm going to cross it out so I don't use it again, and write a 0 as a placeholder. Now I'm going to multiply everything by the 1 that's in that tens place. So 1 times 8 would give me 8, and 1 times 1 would give me 1. So I add up these two numbers. 4 plus 0 is 4. 4 plus 8 would give me 12. Carry the 1. So I would end up with 324. That means 8 squared is 324. So if you forget something, it's not the end of the world. Just work it out. Use those old multiplication skills that you learned back in elementary school. Next, we're going to kind of skip over the page on square roots because we're going to go through that tomorrow, but we're going to flip to that last page that we glued in. And on the left-hand side, we have some perfect squares, and on the right-hand side, we have our square roots. So again, we will fill out this side tomorrow. We're going to look at this left-hand side right now. So in the left column, you have your exponential form. So that's where I'm writing my number using an exponent. We're going to take that number that's in exponential form and then write it in expanded form. So expanded form is when I write what the exponent is telling me to do. This exponent is telling me to multiply the 0 by itself. So expanded form would be 0 times 0. Again, just going back to what we did with our graph paper. So when we did our graph paper, we basically wrote it in expanded form first and then wrote it in exponential form. We're kind of undoing it and going the other way right now. So 0 squared means 0 times 0, which of course would give me 0. 1 squared would mean 1 times 1, which would give me 1. So for the first couple examples, we have numbers where it's kind of the same number all the way across. Now it's going to start to vary a little bit. So 2 squared would mean 2 times 2, which of course when I do the math would be 4. 3 squared would mean 3 times 3, which then would give me 9. And what you can do right now is kind of test yourself here. What we did in class is we went through and we wrote everything in expanded form first. And then I said, see how far you can get with doing that multiplication in your head before you pull up Desmos. So I'm going to show you how to use Desmos, the keys on Desmos you can use in just a second. But first thing you want to do is go ahead and fill out everything in expanded form first, because that's the easy part. So whatever number is squared, I just multiply it by itself. So 4 squared, 4 times 4, 5 times 5. And you can take a second and do this on your own. And you'll be responsible for knowing all the way to 20 squared. So that's what we have in our notes. All right, so now that we have everything written out in expanded form, you can probably do through 10 without Desmos. So we'll go ahead and do that. So 4 times 4, that would be 16. 5 times 5, 25. 6 times 6, 36. Some of these we did with some of our daily challenges. 7 times 7, 49. 8 times 8 would be 64. 9 times 9, 81, and 10 times 10 would give me 100. Now at this point, once you get up to like 11, like once you get past 10, you might want to use Desmos for some of this. So once you have Desmos pulled up, you can type this in a couple of ways. So my next problem here is 11 times 11. So if I know that 11 squared means 11 times 11, I can type in 11 times 11 in Desmos, which would give me 121. I can also use the exponent key. Now, some of this, again, you won't have for this unit, but as we get into other units that involve exponents, or any word problems that involve exponents, you will have Desmos. So I want to make sure you know how to use it. Again, you'll get to use it for some situations and not others, but as we're filling this out, you can use your calculator to get it filled out. So I can also use, again, that exponent key. So I would type in 11, and then right here where you have the A with the squared symbol above it, that's what I'm going to click for it to square the number for me, and it automatically does that. Again, it also gives me 121, which is the same thing I got when I multiplied basically the expanded form. So I would get 121 for both versions of that. So 11 squared would give me 121, and I'm not going to show the calculator for all of this, or you'd probably get dizzy going back and forth. but you know how you can do it on your own if needed. 12 times 12, or 12 squared, would be 144. 13 squared, 169. 14 squared, 196. So I remember these two, 13 squared and 14 squared, are very similar. It's just like you flip-flop those last two digits around. So the 6 and the 9 kind of trade places there. 15 squared, or 15 times 15, gives you 225. 16 squared, or 16 times 16, is 256. 17 squared, or 17 times 17, would give you 289. 18 squared, or 18 times 18, would give you 324. These two we actually put on our notes page, or we worked it out by hand. 19 squared, or 19 times 19, gives you 361. And the biggest number you'll have to memorize, 20 squared, or 20 times 20, is 400. So I can remember 20 squared pretty easily. It's kind of like how 10 squareds are really easy. So 20 squared is 400. I know 19 squared is pretty close to 20 squared. So if I have different numbers I can pick from, or I know what some of my perfect squares are, I know 361 is pretty close to 400. So it makes sense that the number that I'm squaring that's really close to 20 have a perfect square that's pretty close to that 400. So we're going to work on memorizing these. What's important to know is what is what. So again, this far right hand column, those are your perfect squares. Okay, this 2 right here is not the perfect square. The 4 is the perfect square. So only the numbers that are in this right hand column are perfect squares, because those are numbers that you can get by multiplying a whole number by itself. So just that right hand column.